Hello everyone. This video will show how to verify if the two given functions are inverses of each other using the composition method. We remember that two functions f of x and g of x are inverses of each other if and only if f of g of x is equal to x and g of f of x is equal to x. To better understand this, let's go over some examples. In this example, we are given two functions, f of x and g of x. We're supposed to verify if these two functions are inverses of each other. Now, we remember that if f of g of x is equal to x and g of f of x is equal to x, then they are inverse of each other. So that's what we need to find out. So let's go over this composite function that we have right here, f of g of x. So in this problem, the outer function is f. So that means we're going to set up the f of x here. So that would be 4. And then we put the x into a parenthesis. And then that's a cubed plus 5. And then inside this parenthesis is the g of x. So I will write this into the parentheses right here. Looking at this, we can go ahead and cross out the cubed and the cube root. So we are left with, from here we can cross out 4 and 4. So this goes away. So the leftover would be, and then negative 5 plus 5 is a 0. We can cross it out. So we are left with x. So we have shown that our f of g of x is equal to x. Now let's look at the other side also here. Is g of f of x is equal to x? So I'm going to go ahead and set up the equation right here. So the outer function that we have here is g of x. So I'm going to go ahead and rewrite this. And the one that I put into the x of the g of x is the f of x, which is 4x cubed plus 5. So we're going to go ahead and simplify this. So in this problem right here, we have a negative 5 and a positive 5. So we can cross this out. So then we go ahead and rewrite this further. So this is the cube root of 4x cubed over 4. From here, we can cross out the 4 and 4. So we are left with the cube root of x cubed. Now, we remember that the antidote for cube root is cubed. So we can go ahead and cross this out, the cube and the cube root. So we're left with just x. So our g of f of x is equal to x, which tells us that since both of them are equal to x, we can go ahead and say that these two functions, f of x and g of x, are inverse of each other. Now let's go over another example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over this problem. Okay, so we need to figure out if f of g of x is equal to x or g of f of x is equal to x. So we're going to start with this other side right here. So the outer function that we have here is f. So I'm going to write the f of x here. So our g of x will be put into the x of the f of x. From here, we can go ahead and distribute the 3 to each of the terms inside the parentheses. So this would come out. Now, we want both of them to have the same denominator, so we can add them together. So I'm going to go ahead and multiply 4 over 4 to 4. Since they have the same common denominator of 4, I can go ahead and simplify this. This is the simplified form for the f of g of x. Notice that it doesn't come out x. Now let's look at the other composite function right here. So the outer function here is g of x. So I'm going to go ahead and rewrite this. So in this g of f of x, I'm going to put the f of x into the parentheses, which is 3x plus 4. So we go ahead and simplify this. Notice that our g of f of x is not equal to x. So both of them are not equal to x. This tells us that these two functions, f of x and g of x, are not inverse of each other. Did you get the same answer as this? Good. Perfect. So that is how we verify if two functions are inverses of each other using the composition method.